let's get started on Chapter 5, Network Protocols. In this chapter, we will discuss TCPIP, and you will probably find this to be the hardest chapter and the longest chapter, but you will also find it to be the most valuable chapter because TCPIP is the protocol that connects computers, the protocol that allows computers to communicate. So in this chapter, we will look at TCPIP. We will look at the IP address, the subnet mask, and the default gateway. We will look at the IP config and ping commands, and we will look at rules and IP addressing. We will look at the dynamic host configuration protocol, the automatic private addressing protocol, private IP addressing in binary, subnetting, and IP version 6. So let's start out on page 208, TCPIP. We say TCPIP as if it's one protocol, but it's not. It's two protocols. The TCPIP protocol is made up of IP, the Internet Protocol, which is used to send packets and to route packets, and it's made up of the TCP, the Transmission Control Protocol, which is used to send acknowledgments and send negative acknowledgments and to perform flow control. IP sends the packets and TCP sends acknowledgments, and together TCP/IP provides for communications between computers. Let's look at TCP/IP on a Windows 7 computer. If I click on the Start orb, and then I click on Control Panel, and then click on Network and Internet, followed by the Network and Sharing Center, followed by Change Adapter Settings. If I right-click on my Ethernet card and select Properties, I can then see that the Internet Protocol version 4, TCP/IP v4, is installed on this computer. And if we look at the description, we can see that the Transmission Control Protocol, Internet Protocol, is the default wide area network protocol that provides communication across diverse interconnected networks. If I click on the Properties button, I can see that this computer has an IP address. An IP address is a number which is assigned to a computer. So what's an IP address? Well, what's a phone number? A phone number is a number which is assigned to a phone. And why do we have phone numbers? So we can call each other. Similarly, an IP address is a number which is assigned to a computer, and the reason we have IP addresses is so computers can communicate with each other. This computer has an IP address of 10.0.0.1 with a subnet mask of 255.0.0.0, and we will discuss subnet masks later. Subnet mask of 10.0.0.1. So an IP address is a number which is written in a dotted decimal notation, such as 10.1.5.101, and each one of these values is called an octet because it's made up of 8 bits. In IP addressing, all computers must have an IP address, and it's our job as technicians to assign an IP address to every workstation and every server. So let's say I have a freshly installed network right here. We've dragged all the computers in, we've put them on the tables, we've connected all the cables, but now what we need to do is to configure IP addresses on each one. So I will give the first one an IP address of 10.0.0.1, and I will assign the next one an IP address of 10.0.0.2, and as you can imagine, I will give the third one an IP address of 10.0.0.3. So how do you do that? Well, you walk up to the computer and you click on the Start orb, then you click on Control Panel, followed by Network and Internet, followed by the Network and Sharing Center, and then you go to Change Adapter Settings. Then you right-click on the Ethernet card and select Properties, and under Internet Protocol version 4, we click on Properties. and then I type in the IP address of 10.0.0.1. Then I go to the next computer and I give it an IP address of 10.0.0.2. And then I go to the next computer and give it an IP address of 10.0.0.3. Whatever you do, don't give two computers the same IP address, because if you do, then neither one is going to work. If you give two computers the same IP address, this is the error message you're going to get. It's going to say Windows has detected an IP address conflict. And it's a real easy mistake to make, giving two computers the same IP address, especially when you're working late and you're typing in an IP address to a lot of computers. So we've assigned IP addresses to a single network here. What if we have multiple networks? Well, here's our original network here. And what if I install an additional network right here? The question is, what IP addresses will I give to the workstations on this network? Well, first I've got to connect the two networks together. So I get a router and I connect the two computers, the two networks together. Then I got to give IP addresses to these computers. Well, if the ones on the network on the left are 10.0.0.1, 10.0.0.2, and then .3, wouldn't it be reasonable to give this one an IP address of 10.0.0.4? Can't do that, because that would violate the rules of IP addressing. That would have two different networks would have the same network ID, and that violates the rules of IP addressing. So the computer on this network has to have a network ID which does not start with 10. So I will just give this one an IP address of 11.0.0.1. And the next one will be 11.0.0.2. Notice all the computers on this network start with a 10, all the computers on this network start with an 11, and all the computers on each network have different host IDs. Now, one thing I didn't mention was assigning an IP address to the router. A router has two network interface cards in it, and each one gets an IP address. So when we assign an IP address to the router, we have to give one IP address to each network card in the router. So I will give this router the IP address of 10.0.0.1, and I will just change this workstation to .2 and this one to .3. Similarly, I will give this network interface the IP address of 11.0.0.1 and change this to .2. So let me just slide these all up. So now what I've done is I've given the first network card in the router the IP address of 10.0.0.1, then the first workstation is 10.0.0.2, the second is 10.0.0.3, and the third computer is 10.0.0.4. Similarly, the second network interface card in the router will be 11.0.0.0.1. And then the first workstation would be 11.0.0.2, and the second workstation would be .3, and the third workstation would be .4. So this leads to the rules of IP addressing, which you've probably figured out by now. The rules in IP addressing says that all computers on the same network should have different host IDs, but they should have the same network ID. So if we look at the network on the left, they have different host IDs. This one is .2, .3, .4, and they have the same network ID. They all start with 10. And then no two networks should have the same network ID. This is network 10, and this is network 11, so no problems there. Now let's look at the subnet mask. When we configure TCPIP, not only do we enter an IP address, but we enter the subnet mask. The purpose of the subnet mask is to tell us what part of the network ID, which part of the IP address is network ID, and which part of the IP address is host ID. If it has a 255 under the octet, that tells us it's network ID. If it has a 0 under the octet, then that tells us it is host ID. So if you look at this example right here, an IP address of 10.0.0.2, it might be kind of obvious to you that it's network 10 workstation 2. But let's look at this example right here. It's not really clear which is the network ID and which is the host ID. Now, is this network 1, workstation 1.1.1, or is it network 1.1, workstation 1.1, or is it network 1.1.1, workstation 1? Without the subnet mask, you don't know. In this example, a subnet mask of 255.0.0.0, what they call a Class A subnet mask, indicates that only the first octet is network ID. So this IP address is network 1, workstation 1.1.1. The next example, a subnet mask of 255.255.0.0, tells us that this is network 1.1, workstation 1.1. And in the third example, what is called a Class C subnet mask, we can see it's a subnet mask of 255.255.255.0, which tells us that it is network 1.1.1, workstation 1. So it's the difference between living at 111th Street versus living at 111 First Street. In this example, this is a Class A subnet mask. It indicates that it's network 10, workstation 0.0.2, because you can see the subnet mask is 255.0.0.0. In this next example, it's a Class C subnet mask, a subnet mask of 255.255.255.0, indicating that this is network 192.168.1, workstation 2. A Class A subnet mask is 255.0.0.0, indicating that only the first octet is network ID. Conversely, at the other extreme is a Class C subnet mask of 255.255.255.0. This tells us that the first 3 octets are network ID and the last octet is host ID. In a Class C network, you can have a maximum of 254 host IDs. Why? Because there is only 1 octet with which to assign host ID, and there are only 8 bits in an octet. Default gateway. When we configure TCPIP, we configure the IP address and the subnet mask and the default gateway. The default gateway is the IP address of the router. It's the way the workstation gets to the outside world. For workstation 10.0.0.4, you can see that it connects to a router, the default gateway. Now, if workstation 10.0.0.4 is going to send data to workstation 10.0.0.3, then it just sends it to 10.0.0.3. But if workstation 10.0.0.4 is going to send a packet to a computer which is not on the same network, then that packet must go to the router, to the default gateway, because that is the access to the outside world and to the internet. We can see the default gateway is 10.0.0.1, which is the IP address of the router. So when we configure TCPIP, we walk up to each individual computer and give it an IP address, subnet mask, and a default gateway. In the next section, we will talk about testing TCPIP. And this concludes Part 1